Okay, so let us start our journey today from the beginning, that is with fundamentals of networking. Okay, so before we dive into the IP addressing concept, so let us have this terminology with in terms of layman. Okay, now imagine this is my mobile and this is Sharan's mobile. Okay, now if I say to my mobile, I imagine that I don't have Sharan's number, but I will say call Sharan. So will it dial? So will it dial, yes or no? Or if it will say no. It says I don't know what you mean by Sharan, right? Because no number found, right? So similarly, it is the other way around from Sharan's mobile. So even he doesn't have my number. Okay. So he will also say call Mithun from his number. So it will give the same result. Okay. Because why this happens is the devices, whether it is a mobile phone or any device for that matter, they don't understand this naming convention. Naming convention is only for humans like us. Okay. It is for our usage. We use names. Okay. What devices understand is something like this. Some number it should have. Only then it will dial. Okay. Right? So only when I say to my mobile, even though I don't store it, I need to dial some 10-digit number. 99999 some random number. Then what it will happen? So it will reach the network provider. Okay, and from here it will reach Sharan's mobile. Okay, because this identity is unique. If this number belongs to Sharan, so only this is a property of Sharan. So nobody else will have the same number. Okay, so same concept is also with the computers. Okay, but they don't have a 10-digit number. So computer also, if you want to send or receive a message between two computers. Okay, now this is the very smallest network, I would say. But in order to exchange the information between this device A and device B. Okay, so this is device A and this is device B. Okay. So similarly, what happens? It has a IP address. Okay. Now, IP address will have a format of what? Now A dot B dot C dot D. Okay. And /X. Similarly, even this device will have a IP address. Okay. It can be like E dot F dot G dot H/Y. Okay. So it will be in this format. Okay. Only then you will be able to send or receive the data from device A to device B. Okay. So this is the basic understanding. Okay. Now until so far, any doubts? Clear, right? Any doubts so far?
No, sir.
Okay. Now coming to why people have selected this format A dot B dot C dot D. Okay. Now going to that format is, now I will share this with you as well. Now, now why this is of, now I'll write one IPv, so IPv4 address. So that is what we are following now, the IPv4 addressing format, because that was decided in the early days when they started with networking. Okay, so this is of 32-bit. Okay, so these are all important interview question. Okay, so why 32 bits? Because when first the internet was formed, at that time any process, so 32 bit was the highest bit any processor could have. Okay, so everyone knows that for any devices there will be a motherboard like processor, right? So at that time 32 bit was the maximum or the highest bit. Okay, now this was in the form of like, so this has 4 periods. Okay, say now I return that A dot B dot C dot D. Okay, and so this is what a dot is called the period. Okay, so let me label it for you. So dot is called the period. Okay, okay. See, this dot is called the period, and every octet, and this is called octet. Why octet? Because in each octet it has a 8 binary bits. What it has? 8 binary bits. What it has? 8 binary bits. Okay, and these 8 bits we write from right to left. Okay, so I cannot write from right to left because this is a laptop, so I am going to write left to right. Okay, so 2 to the power 7, 2 power 6, okay, 2 to the power 5, 2 to the power 4, 2 to the power 3, 2 power 2, 2 to the power 1, and 2 to the power 3. Okay, so this will be there in every bit. So A will have these many bits, B will have these many bits, C will have these many bits, and of course D will also have that. Okay, I think I forgot to write this. This is not 2 power 1, this is 2 power 0. Okay, now let us write the value. What is 2 power 7? So 2 power 7 is 128. 2 power 6 is 64. 2 power 5 is 32. 2 power 4 is 16. 2 power 3 is 8. 2 power 2 is 4. 2 power 1 is 2. Okay, and 2 power 0 is. So these are the values. So this value will be there in everything, right? Got it? Now, if you add this, okay, if you add all the digits, now, if you add all the digits, so you say in binary what happens, the computer understand only the sequence of zeros and ones, right? So what I'll do, if the value is 1, that means true. Okay, that means what will the value? Now if in all the binary bits I have replaced with 1, that means true, all the binary bits are true. That means we need to add the value, that is 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is equal to 255. Getting it? So you can add parallelly. You can add and verify the result. Anybody want to try adding?
Yes, sir, I added, sir, to 255.
Yes, yes, 255. Okay, now similarly, what another possibility? All the values can be 0. Obviously, no need to calculate. You can straight away write. So that means any IP address, the lowest possible value is 0.2. This is the lowest possible IP address. And friends, this is an important question, and this is the address of the internet. So if someone asks you what is the address of the internet, so this is the address of the internet. 0.000 means it can mean anywhere. Okay, so this is the lowest possible IP address. And then what is the maximum possible IP address? 255.255.255. This is the maximum, or say highest possible. Right? If all are true, that means it is a okay. Now this kind of IP address, so this will be used as subnet masking. Okay, I'll come to subnet masking in the coming slide. Okay, now for now what you have to understand is this is the lowest possible address and this is the highest possible address. Okay, clear? Now, then after they figured out, okay, we will have 32-bit and blah 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 everything. Now they also segregated the IPv4 addresses into several classes. Okay, clear? Now they segregated into IPv4 classes. Okay, that means class. So what are the classes? So class A, class B, class C, and class B. Okay, and what rule they made? Okay, so along with these classes they made one rule. Okay, so let me tell you what are those rules. Okay, anybody having this idea?
Hello, sir.
Yes, Raj, tell me.
Sir, one second, sir. Question, one second, sir.
No, see, in the initial days, IPv4 classes were divided into groups. So can
Yes,
you
sir.
tell me what are those groups?
Sir, class A, class B, class C, class D. Class C for small organizations, sir. Class A for IP starts from 252 star. From it start from 250, sir. Class C is like 191 or 190. It starts from 192, sir. So each classes is divided by larger organization based on the requirements, sir.
Yeah. So one rule they made is class A should have from 0 to 126. Okay. If someone says 127 but 127 is used by loopback address. Okay, I will tell you what is loopback address later. Okay, so you can say 0 to 126, or let me put 127 also. Someone says 127, but that is debatable. Okay, then 128 to 191 is class D. Okay, and then 192 to 223. Okay, and class, see, nobody used 2 to class 4, so 224 to 255, right? Clear? So this was the terminology. Okay. Now let us forget about class D. They were only focused about, I will just write 224 onwards. Okay. Now we are in an era of classless inter-domain routing. Okay. So forget about classes. So we nowadays we don't use classes that much. Okay. Now along with this numbering, they also made one more rule. Okay. What is that rule? They told that if you are going to use class A, then they made a rule that your subnet mask should be /. I'll tell you what is the subnet mask later. Now, they also said that if you are going to use class B IP addresses, your subnet mask should be class A. Okay. Right. Then, if you are going to use class C, your subnet mask should be /. Now, you may be thinking, what is this /8/16? It's very easy. No need to panic. Now, /8 means they made a rule that, boss, if you are going to use a class A IP address, now this is a class A because this number is between 0 to 126, obviously. So, I will write 10.0.0.0. Now, this is one IP address. What they made the rule is, if you are going to use this IP address, boss, don't use this for your hosts. Means this is a network address. So that is the rule they made. This is a network address. Means all the binary bits will be 1. So that means this is a network. This is a network bit. Okay. And let me take another color, and this whatever I am highlighting in yellow, this is for host. Host bit. So this means what?
Sir, this is for class A or class O?
Class A. This is for class A. Whatever I am explaining is for class A.
Okay.
Okay. Class A. This is for class A. Okay. Network bit, and these are all host bit. This means what? So, what is the subnet mask then? So, this means if the first bit is for network, then all the values are 1. Then the first value will be 255. So, .255.0.0. So this will be the okay. So this means 255.0.0.0 is the subnet mask. Okay, so this is the subnet mask. Why subnet mask? Because /8 means 255.0.0. Because we are only using this as a network. Now this part we cannot assign to the network. So this means class A was the what? Was the highest class having the highest number of IP addresses. How? Because that means now in the interview they will pakka ask you, they will give you one CIDR. Okay, and they will ask you how many IP address can we have. So if subnet mask is 255.255.0.0, so how many IP address will get? So there is a trick to this.
ಅದನ್ನ ವೈಟ್ ಕಲರ್ ಕೆಳಗೆ ಹಾಕ್ಬಿಡ್ರಿ. ವೈಟ್ ಕಲರ್ ಹಾಕ್ರಿ.
Okay, so this means that where was I? Yeah, subnet mask. So this means there is a trick to it. So IPV4 is 32. So what is the class A? subnet mask is /8, just minus 8 from 32. What value you will get? 32 minus 8 is how much?
24.
So for this 24, let us calculate 2 to the power 24. So how much we will get? What is 2 power 24? Can anyone tell me? So
16
2 power
7
24
216.
is, that is 1 times 100, 1000, 10,000, lakh, 10 lakh crore. So 1 crore 67 lakh 77,267 IP addresses. So you can have 1 crore hosts in a network. Okay. So how many IP addresses? IP. So this is the biggest. Okay. Now similarly, okay. Now coming to class B. Okay. Now I will explain the class B here. Okay. In this right hand side. Okay. Yeah. So class B, what rule they made? Okay, boss, 128 to 191. Fine, that is totally fine. And what's the CIDR range? /16 you must use. That means now let me write a class B address. So 128.0.0. or I will put 128 dot say 100 then 0.0. I will explain you why I took 100. Okay, then /60 like this. So what, as per the rule, what they made is, if you are using class B, these two are for network. Okay, and these two and these two are for host. Okay, so this is a network, this is for hosts. So that means you cannot assign this bit to the hosts. So that means this, the subnet mask will be 255.255 because both the octets, means both the binary bits, that is 0 to 7, 8 bits will be 111. So that is 111 means 255.255 and 0.0. So this will be the subnet mask for class B. And how many IP address will have? Simple, just do. Okay, so now this is the subnet mask. Okay, now let me write it here. Subnet mask, and how many IP addresses? That's 32 minus 16. So we'll get 16 and 2 to the power 16 is how much? 65,535 or 36 IP addresses. Clear? Clear? So we discussed class A and class B. Now you guys tell me for class C. I have already shown you for class A and class B. Okay. Now you tell me for class C. What is going to be the scenario? Tell me. Anyone? Okay. So class B, similar, it is /24. Okay. The subnet mask will be 255.255.255.0. Okay. And
256, sir. 256 IP address.
yeah. So 32 minus 24. that is 8. So 256 IP addresses. Okay. So in AWS, we cannot use class A. I will tell you why. Okay, this we cannot use. I'll put it in yellow. So we can't use this /8. The maximum is we can use is /16. Okay, and the minimum is /29. I will explain why, how 29 came, how and all. Because the possible CIDR ranges, we have only class A, class B, class C. Okay. Now let me. So class C, you have to, everyone have to do on their own as a homework. I am going to put this in the chat. Okay, for your reference, you can refer later. Okay. Next. Now, even though we have these many classes and each class will have these many IP addresses, but this created a IP shrinkage. Now, what do you mean by IP shrinkage? Means the customer were forced to select the classes, and it made them somewhat restricted, because okay, if you are selecting class A, you will have many network. If you are using class B, you will have much lesser than class A, and if you are class C, then we'll have 256. So this created some shrinkage or shortage, IP shortage. So that is why they went with the concept called as CIDR. What is the CIDR? This is classless inter-domain routing. Now this is what we are using nowadays. We are no more using classes. We are using classless inter-domain routing. Now what is this classless inter-domain routing? This means we are not bothered about classes. There is no restriction. You may pick any number you want. I may pick 10 series. Okay, and I can put /24 or /26. Nobody is going to stop me. Right? And how this works? So let me explain. So for example, now let me write an IP address for you guys. Now let me write an IP address. Say 10.100.0.0. Okay. Now how will you represent this in binary? Very simple. You remember that this formula 128, 64, 32, 16, 8, 4, 2, 8, 4, 2, 1. Okay. So you need to put 1 in such a way that if you add those digits, you should get that value. For example, I'll put 0, 0, 0, 0, 1, 0, 1, 0. Now this is how I represent 10. Okay. So how will I write 10 now? 0, 0, 0, 0, 1, 0, 1, 0. Okay. So I represent 10 as this. Now tell me for 100. So 128 obviously it is greater than 100. So I will put 0 here. Yes, I may put 1 here because. So then what is 64 plus 32? 60 plus 30 is 90. 94, 96. Yeah. And then 0, 0, 0. How much I told? 60, 96. Yeah, here I'll get 1 and 0, 0, 0. So coming back here, dot, I will represent 100 as 0, 1, 1, 0, 0, 1, 0, 0. And remaining thing is 0, 0, 0, 0, 0, 0, dot 0, 0, 0, 0, 0, 0, 0. Now this, so this IP address will be represented as this. Clear? Now the same IP address, this is what we see and this is what the device will see. Okay. Computer is least bothered about this. Okay. Computer only understand this sequence. Okay. So computer will understand this and we understand this. Clear? Okay. Now classless interdomain routing means, now say you can pick a class between A and B, B and C and A and C also. Right? So now with respect to, now we are going to discuss only with respect to the AWS. Okay. All, not only AWS, all Azure, all other major cloud providers like Azure and GCP, they all follow the same strategy. Okay. The maximum is /16. Okay. Now what if I pick up /17 or 80? Okay. Now the same IP address, what if I pick 10.100.0.0/70? Now this is a CIDR. Now this /16, now you may be getting confused because where does this which class does this belongs to? Whether it is class A or class B. Now this is in between class A and class B. So what they will do is, now listen to this carefully. /16 means, so I cannot pick first octet, second octet because 8 plus 8 is 16. Right? Now 17 means the one more bit. Now this is the additional bit, you can borrow it from the next octet. So this is what classless interdomain routing is. Understand? So if it is 17, then again one more bit. 18, one more bit. So like that it will keep on adding. Clear? Then if suppose what if the CIDR is 17, then what will be the subnet mask? So the subnet mask will be changing. So that is 255. So first octet is 255. Then 255. Okay. Now this is not 0. What is the first? So first octet. So we have borrowed the first octet from the, first binary bit from the third octet. So that means that it will be 1. That is 128. So 128. So this will be the subnet. This is clear. Now if you are facing any difficulty, there is a one beautiful website I will tell you today, that is CIDR.xyz. If you are facing any difficulty, you can put here. So what value I put? So 10.100 0.0/70. See what I told? What is the net mask? 128. Is my calculation correct? See, 128. So this is how classless inter-domain routing works. So this is a advance they made in IPv4 addressing. So wherein you can borrow from the next octet. So this is very, very important concept with respect to interview. And in any cloud nowadays, we are going to use CIDR only. And any IP addresses will be of the format like this. There will be a /x. Clear everyone? Any doubts so far? Okay. And you should always remember the formula. The higher the CIDR number, okay, the lesser the number of IP addresses. Okay. Because the higher the number, it is going to occupy the bit by bit. Okay. So this is the subnet mask. Okay. So it is very easy. Once you understand this concept, it becomes very, very easy in networking. Okay. And believe me, cloud is all about 50 to 70% is all about networking concepts. If you are good with networking, you can crack any interview, you can crack or you can troubleshoot any issue because all is based on IP address. So that is why I am stressing more on IPv4 addressing. Okay. So this was about the basics, fundamentals of IPv4 addressing, then classless inter-domain routing. Now I will share you some PDFs as well. See, this is whatever I have explained so far. Okay. See, same thing I have explained. Okay, so I will share this with you guys. Okay. See, theoretically, how many 4.3 billion IP addresses are available? Okay. Why? Because 2 power 32 is 4.3 billion. Okay. See, the network address and the host address. It's a detailed explanation they have given. So this is for your reference. Okay. I have already explained this. Okay. So you can go through. I will share it with you. Okay. Subnet masking, everything I have. Okay. Yes. Now, few more things to consider. Okay, before we wind up this session for today. Now, every device has a unique MAC address. So, okay. So, how will you find that? Just press start button and R. Okay. And type CMD. And just type ipconfig. You will have a unique hardware MAC address. Okay. So this is the MAC address. So physical address, what you see, this is the MAC address. So this will be unique. You can check in your laptop also. Okay, so this is the MAC address. Okay. Okay, so this will be in a, okay, so every device on a node has a unique MAC address. Okay, and every device needs a unique IP addresses, right? Because same way, for example, me and Sharan cannot have a same mobile number, so it will have a conflict, right? So same way, two devices on the same network cannot have a same private IP address. Okay, so that is why we have unique IP addresses. Okay, and all devices on the same physical segment share a common network ID, that is called subnet mask. So that is why we have a subnet mask. Okay, see, now next concept is address resolution protocol. Now what is this address resolution protocol? Before an IP packet can be forwarded to another host, the MAC address, usually that is of 6 bytes written in hexadecimal, of the receiving machine must be known. Okay. Okay. So whenever these two nodes wants to communicate with each other, so basically it will start with the address ARP, that is address resolution protocol. Okay. So the ARP protocol is responsible for that is pointing the IP address to the MAC address. See, ARP determines the MAC address that corresponds to an IP address. Then a router will choose the direct paths for the network packets based on the addressing of the IP frame. Okay. See, these are all advanced routing concepts. Okay. So there will always be a router in between. Okay. If you take, now let me show you one. Now this website you bookmark. Okay. It will be helpful for you guys. So you can bookmark. IP address and subnetting. So you can refer this. Okay. Now the next concept is, yeah, now I will show you a simple architecture like AWS VPC architecture. See, this is the simplest architecture. See, there is a router. There will be a router always. Okay, you take any network for that matter. There will be a router who is going to forward the packets from one node or one VM to another VM within the network or outside the network. Okay. So this is one concept, and then after IP, okay, I didn't share you, right? Wait. Let me share you this. Okay, and okay, let it load. Okay. Now coming to this networking, okay. So in any network for that matter, there will be something called as a client and a server. Okay. Now this to understand this, so suppose if we all go to hotel, right? So do we go and talk to the cook directly? Or if you go to any market, so there will be someone to address your requirement, right? Suppose you ask something and they will give you something. Okay. So in a simple analogy, you are a requester and he is a provider, right? So same way in computing world also it's the same thing. So there is a client server architecture. Wherever you go, this is the same. Okay. Now I am browsing this page, so I am a client. Okay. Now I am a client for this tutorials point. I am using their service, that is I am using one of their application which is whiteboard. So I am a client and it is a server. Okay. This application is also hosted on some of the virtual machine for sure. Okay, so there will always be a client server architecture. See, whenever you request from your laptop or PC or your mobile phone, it is a request. You are sending a GET request. Okay, so you become a client and that is a server. So that is why all the virtual machines are, it is a server. Okay, the example is client is a radio receiver in our car and server is a radio station. Okay, and this is another they have given in the address. Okay, so an IP address is similar to a street address. Okay, so part of the address decides where in the world the building is located. Okay, so by looking at the CIDR range, you can tell to which network this belongs to. Clear, right? So to which network it belongs to. Okay, clear? Any doubts? And if any device wants to communicate with the outside internet, then that should have a public. See here, so this is what. Okay, so this is a public IP, and inside this is a barricade where only this house will talk to this house, and this house can talk to this house because they are inside this virtual network. This is a private network, but this is a public network. Okay, if this house needs to talk to another community or another gated community, this has to go via this public IP. Okay, so this will dive deeper tomorrow. Okay, so today you just practice this concept. Okay, and read this book. I will share it with you. Read these two in depth because these are all the basics, fundamentals. See, we don't require to read network hubs and switches. If you are interested, you can read. That is, see, network hubs and switches are for advanced networking concept. Okay, you can read if you want, or else not required. Let me show you this. So any doubts before we wind up the class? Nisha, Vinuta, Rajshekar, Sharan?
No, sir.
Okay. So
No, sir.
Okay. So from tomorrow it will be hands-on. Okay. Now we have completed the basics. So from tomorrow we will start building the VPC. Okay. With of course we will start with the introduction and then we will build the VPC. Okay. Clear? Okay. Then thank you.